Hello again, this is Mr. Rupp, and we're going to be talking about mixed expressions and complex fractions in section 11-8. Alright, so mixed expressions and complex fractions. We'll take them one at a time. From the definition you see here, mixed expression is an expression that contains a mix of monomials and rational expressions. Alright, so for example, if you had, just like a number, if you had 2.5, okay, that's called a mixed expression, a mixed fraction, because you've got a 2, which is a whole number, and a fraction that's a half. Alright, well, just like that, a mixed expression is if you had something like 3 plus, what is it, x plus 2 over x plus 3. Okay, now you might look at this and think that is just bizarre, and it's like made up, it's a contrived problem, and it is. But I'll tell you, in the real world, math is not very neat. Okay, you learn neat math in order to learn the math, but when you get into the real world, you get into really nasty looking equations, you get nasty looking problems, because they're real life. Okay, all right. Mixed expressions, okay? Let's go down and do this example here. Oh yeah. And this example is going to be on page 620. Oh yeah. So, it says simplify 3 plus 6 over x plus 3. Well, all of the previous sections you've been working on, rational expressions with like denominators, unlike denominators, they all come into play here now. Alright, what do you have to do to the 3 to get it into a like denominator of x plus 3? Okay, well, pretty obvious. You need to multiply it, top and bottom, by x plus 3 over x plus 3, because that whole quantity is equal to 1, plus 6 over x plus 3. So this becomes 3 times x plus 3, and then plus 6 all over a common denominator of x plus 3. Alright, so we have 3x plus 9 plus 6 all over x plus 3. So we have 3x plus 15 all over x plus 3. Going back over here, out of 3x plus 15, what can you factor out? Well, you can factor out a 3. Alright, you could factor out, I'll rewrite it here, 3x plus 15 all over x plus 3. Alright, you could factor out a 3, and that would give you 3 times the quantity x plus 5 over x plus 3. Like I said, either one of these is satisfactory for me. The book goes with this version of the solution, which makes sense because it doesn't have any parentheses in it. Now, if you could factor out an x plus 3 over here, then the x plus 3's would cancel, and that would make it worthwhile, and then you would have just 3 left over. Okay? But as it stands, 3x plus 15 over x plus 3 is your final answer for example 1. Moving on. More fish head. Yeah. Okay, sorry. Carried away there. Alrighty. So here now we have complex fractions. And if you thought fractions were bad, complex fractions are bad squared. A complex fraction is a fraction that has one or more fractions in the numerator or denominator. Or both. That's right. So here's an example. Here's a numerical example of this. Alright, so the book has 8 over 3 divided by 7 over 5. Now remember, this is where I tell you to take this vertically and write it horizontally. So you have 8 over 3 divided by 7 over 5. Okay, so then you keep it, change it, flip it. So you keep the 8/3 you change divide to multiply, and you flip the 7/5 into 5/7. And that gives you 8 times 5 over 3 times 7, or 40 over 21. All right? We're going to mark that up. Well, here's an algebraic example. And we're going to use just straight letters. A over B divided by C over D. Okay? Now you'll notice on both of these, the little fraction bar I've made as a small one, and the bigger one I made bigger, so that it's really easy to tell. Okay? A over B over C over D. That's really hard to tell what exactly is going on there. Alright? So, don't do that. Make the bar in the middle the main one. Okay? Well, this is equal to A over B divided by C over D, right? So now we have A over B, and we keep it, change it to multiply, and flip the other one. So we have D over C. So this is equal to A times D over B times C. Okay? And that brings us to this key concept here, where it says any complex fraction, A over B divided by C over D, where the B's, C's, and D's aren't equal to 0, you can express that directly as A times D over B times C. Okay? Let's look at this. I'm going to rewrite this again. A over B divided by C over D. And I'm going to switch colors here. What you do is you take the top and the bottom and multiply them together over the middles, B and C. Okay? That's a pretty slick method, trick almost. So if you had 1/2 divided by 3/4, well, you don't have to go through the keep it, change it, flip it. You can go directly. 1 and 4 over 2 and 3. 4 over 6. 2/3. Right off the bat. So you don't have to do this keep it, change it, flip it thing if you don't want to. You can go directly and use that method right there. Okay? That's a really cool trick to know. Alright. Change my pen color back here. We're going to do example 2 on page 621 again. Oh, yeah. Well, you know, I figured since we're baking chocolate chip cookies, we should have banana on deck here. Okay, so it says refer to the application at the beginning of this lesson. And I copied that down here for you. So Caitlin bought 2.5 pounds of chocolate chip cookie dough. And if the average cookie requires 1.5 ounces of dough, the number of cookies that Caitlin can bake can be found by simplifying this expression. All right? You take the total number of dough, or the total amount of dough here, and you divide it by how much dough is required for each cookie, and that will give you the number of cookies that she can make, right? It's a pretty straightforward problem, actually. You go back to the problem here and it says how many cookies can Caitlin make with 2.5 pounds of dough. All right. So we go here and we'll rewrite this. 2.5 pounds of dough, and each cookie takes 1.5 ounces. All right, and that will give you the number of cookies. Well, can you take pounds and straight divide them by ounces? No. Banana Head says no. No. What do you have to do? Wait, I'm hearing it. I'm hearing it. Did someone said unit conversion. Yay! Woohoo! Everyone wave your banana peels. Yeah, yeah. Okay. Unit conversion. We have to convert pounds into ounces. Okay? Right. Remember, unit conversion is almost like a forced expression. It's a forced equation. All right, you get to determine what goes on the top and what goes on the bottom. Instead of the math determining it for you, you get to determine it. Do you want pounds out at the end, or do you want ounces out at the end? Okay. Well, really all we want is we want them both to cancel because we simply want number of cookies. Number of cookies has no unit attached to it. You can't have 13 cookies pounds or, 13 ounces cookies. You want just 13 cookies, for an example. You need to convert pounds and ounces so that they cancel. Right. Well, ounces are going to be on top then, because ounces on top will cancel ounces on the bottom, and pounds will be on the bottom for the very same reason. Okay, well, how many ounces are in a pound? 16. 16 ounces into 1 pound. Algebra, I've told you this before. Algebra is a platform math, and it requires you to learn and to know and have at your fingertips all the math that you've learned before. Unit conversion, how many ounces are in a pound, all that stuff. Okay? It expects you to know that now. Okay, well, whipping out our pen of a different color. Pounds will cancel pounds, ounces will cancel ounces, and what are we left with? We're left with, we'll write it down here, 2.5 times 16 over 1.5 times 1. Let's go ahead and do this. So we're going to take 2.5 and 1.5, convert them into improper fractions. So that would be 5 halves times 16 over 1 divided by 3 halves times 1 over 1, right? Right. So then this becomes 5 times 16 is, right, 80. Over 2 divided by 3 over 2. Simple, right? 80 and the 2 go together. 80 times 2 over 2 times 3. That gives you 160 over 6, which is equal to 26 2/3 cookies. Can she make with 2.5 pounds of dough? Not that hard, right? Not that hard. Even Banana Head agrees. Yes. All right. Moving on. Okay. Now this one is a pretty cool one, okay? Because all I have to do is this. Yeah, like that, huh? So example 3 then, on page 622. And it says simplify this guy. This is a complex fraction involving monomials. So we have x squared y squared divided by a over x squared y over a to the 3rd power. Again, remember, the top and bottom fraction bars are smaller than the main one. That helps keep it visually organized. What's this equal? Well, same thing. Okay, you can take it and rewrite this way, where you have x squared y squared over a divided by x squared y over a cubed. And then that becomes x squared y squared over a times, that's the keep it, this is the change from divide to multiply, and then flip it, a cubed over x squared y. Again, I wanted to just do it this way so that I could show you again, it's really this guy oops, times this guy, and this over these two. Okay? Alright? So, you can simplify. Alright, so we have x squared y squared over a times a cubed over x squared y. So let's simplify. This a will cancel with this a cubed and leave it as a squared. This x squared completely cancels that x squared, and this y cancels that squared. So what you're left with is y a squared over, wow, everything cancels. So it's a squared y is your answer. Yeah. Okay. Everybody loves golf ball head. Don't we though? This is our last example, and that's going to be on page 622. All right then. And this is a complex fraction involving polynomials. So it says simplify this guy. So you have a minus 15 over a minus 2 all over a plus 3. And you're like, oh my god, where do I start? Okay, well, you have to pick somewhere to start. And in this case, I would start with the a, because the numerator, start with the numerator, and you look at this and you say a, what do you have to do to a to get it over a denominator of a minus 2? Okay. A minus 2. There we go. So what do we have to do? You have to multiply it top and bottom by a minus 2. Minus 15 over a minus 2 all over a plus 3. So here's what we've got. A times a minus 2 minus 15 all over a minus 2 divided by a plus 3. Alright, so coming down here then, what I'm going to do is I'm going to multiply this top out. I'm going to multiply it through distributed out. So we have a squared minus 2a minus 15 all over a minus 2 all over a plus 3. Like that. That's a horrible line. That was not much better. Sorry. Okay, so again, here's something that you can do. A plus 3 is the same. I'm going to do this in a different color. A plus 3 is the same as a plus 3 over 1, right? It's just over 1. You can still do this top times the bottom over the middle. So if you took a squared and multiplied it by 1, then you're going to get a squared minus 2a minus 15. And that's going to be over these two middle ones. Okay? So it's a minus 2 times a plus 3. So this whole thing here can very neatly shrink to this. Isn't that neat? Okay? Well, this is a polynomial, a quadratic. So what can you do? You can factor it, more than likely. And in this case, the answer is yes. So what two things multiplied give you negative 15 and added give you negative 2? How about this? Oh yeah, a minus 5 times a plus 3. And that's all over a minus 2 times a plus 3. Oh, you know what's coming now, don't you? Oh yeah. We're going to get out a whole different color now. So this a plus 3 cancels that a plus 3. And down here you're left with a minus 5 over a minus 2. And that, my friends, is how it's done. Okay? You like that? I like that. That worked out really well. That was pretty slick. Okay. All right. That's all I got for today. Thank you for watching this video to the end. If you like it, comment, like it, that kind of thing. And this will be the last video in this series, I believe. So, you guys, I love you, I miss you, God bless, and goodbye.